Hello class, welcome to our lesson today dealing with the central limit theorem. We're just going to go through a few questions just to make sure everyone's on the right track in terms of when to use different situations of the central limit theorem. So let's go and get started with this first one. This says Coke cans, regular cans of Coca-Cola, are supposed to contain 12 ounces. 36 cans are sampled and it's found that the mean is 12.19. The population is supposed to have a mean of 12 and a standard deviation of 0.11. Find the probability the can has a mean of 12.19 or greater. So it's the mean of the probability of these 36 cans. So that means when we do our standard deviation piece, we have to divide by root n. So it would be 12.19 minus 12, that's the numerator. Then the denominator to be 0.11 divided by square root of 36. The z-score value should be 10.36 here. And what I'm looking for is the probability that it's greater than 10.36. Oh, this should be a z here, not x. Excuse me about that. Should be a z there. But that would be a greater than situation, so it's 1 minus the 0.9999 number, not addition. Okay, not just area to the left, it's area to the right. So you have to subtract that out, which you get 0.0001. So this is a very unlikely situation because it's less than 5%. That would be unusual statistically. What this probably means is the mean amount of Coke in the can is not 12 ounces. So what happens in this case is actually the mean is greater than 12 ounces, and the reason is to make sure that Coca-Cola doesn't have any issues about getting sued. So the idea is if there was less than 12, what you would be saying on the can would not be accurate. Having a little bit more than 12 is never a problem. I've rarely heard someone complain about getting a little bit extra for the same price. And so what they do is they just try to guarantee that the number will be a little bit higher on average than what the number on the can would say. And so that's why it would be considered unusual in this case. The next two questions deal with a kind of similar idea. I mean, these are so small, plain M&M candies. They're so small that they're going to have some little bit of wiggle room, but most of them should be about the same weight. Which, if you look at how little they weigh and the standard deviation, that kind of makes sense. This data was found from 465 different pieces of candy. The first one says if one piece of candy is chosen at random, find the probability that its weight is at least the 0.8535. Now notice here I didn't have to divide by any square root. Technically I did divide by a square root. It's a square root of 1 for the denominator, which doesn't do anything, which is why we didn't have to worry about it when looking at these scenarios earlier. I'm looking then for the probability that z is greater than negative 0.06. If I do 0.06, negative 0.06, on the z-score table, remember that's to the 4 digits, and that would be 0.4761. To find the answer, then I would do 1 minus that, and then that would give me 0.5239. Remember to use, unless told otherwise, to use the table. Everything should be 4 digits, and you have to be able to use the table in order to find those answers. And again, that's if one piece of candy. So it's very likely, it's not unusual that the piece would weigh at least that much, which makes sense. If the average is a little bit higher, it fits the standard deviation group, and it should weigh at least that, and that would not be unusual. If you take all of the 465 and average them, you're looking at the mean weight of those to be at least at 0.8535. Now notice here I have the exact same formula as the last slide to find z, except it's divided by the root of 465. This means that z is equal to negative 1.25. So notice it was about almost 0 before, negative 0.06, and it moved all the way over to negative 1.25 standard deviations. So I'm saying, well, what's the probability that the mean average weight of all of those is at least that? So it's again a 1 minus question, and I get just under 90%. But notice how much more likely this is. Okay, it's going to make sense because if the average is higher, and we're saying our average amount for each of those candies should be at least getting closer to the average. And so it's much more likely that it will be above average at that point in order to find that answer. These last two questions explain the difference between the two, okay, 1 versus the 465. The idea is very similar to find the z-score value and things of that nature. So you want to pay close attention to that as you're looking at your homework and the upcoming test. The other thing that you want to make sure of is make sure the central limit theorem can be applied. Make sure you understand that what happens when n is greater than 30, what happens when n is less than or equal to 30. Make sure you understand how and when to use the central limit theorem. Have a good day, everyone.